Hello friends, we are going to discuss Neet 2017 chemistry part, 2017 chemistry discussion. This question paper actually has got majority very simple questions, and to be more exact, only 3 or 4 questions are slightly difficult. You can call it level not 3, level 2, slightly more than level 2. Then about 17 to 18 questions are very, very simple. 17 to 18 questions are very simple. And the remaining will be moderate, expected of a normal +2 student. That is regarding the difficulty level. So even if you are not attempting that difficult part, 3 or 4 questions, definitely you will be getting a selection. So don't worry about too much. Don't worry too much about a very, very difficult question. You simply leave it, that's all. You have to study very simple question as well as questions of moderate difficulty. Now another type of distribution regarding physical chemistry, inorganic and organic. It's not an equal distribution. I just examined the paper and found that about how many questions? Inorganic part, it contains about 17 questions. Inorganic part, about 17 questions. That much inorganic. And 11 questions are from physical chemistry. And the remaining, this will be 28, the remaining will be remaining will be organic part. So that also shows that at least in some year, they may be giving more importance to one of the part. Don't expect equal division from inorganic, organic and physical. There may be changes. That actually depends upon the person who is setting the paper. He may be a physical chemistry man. You know, there is some specialization in higher level chemistry. Naturally, if he is a physical chemistry man, he will be an option will be more to the physical part, less for organic. But generally, out of 45 questions, you can expect about 15 questions from every part. That is the normal distribution. Now we directly go to answer part. This question, number 1. Mercury chloride and iodine, both when dissolved in water containing iodide ion, which is the species expected in solution. It is based upon a chemical reaction between iodine and potassium iodide. It will form I3 minus. So if that is the only reaction, your answer should be an ion should be the ion present should be I3 minus. But because of the presence of HgCl2, there is another reaction. That reaction is HgCl2 can give a precipitate with, I will write potassium iodide. It will give a precipitate of HgI2. It's a scarlet red precipitate. But excess of potassium iodide will convert this into HgI2 can again react with Ki, giving K2HgI4. So many possibilities are there. If it is only iodine and iodide, you expect only this species. But in presence of mercury chloride, you can get the species HgI2. And if you have got excess of potassium iodide, HgI2 plus 2 Ki, it will give K2HgI4. So in this question, the possible answer will be this may be expected in solution, because potassium iodide, they are not given how much of potassium iodide present. There will be sufficient iodide ions in solution. But the salt will immediately ionize into potassium ion 2K plus and then HgI4. HgI4 2 minus. That is there. Also, there may be some iodide, excess iodide that will react with iodine giving I3 minus. So the prominent ion as per the given option, the answer can be this one. HgI4 2 minus, according to this reaction, K2HgI4 will give you this particular ion in solution, and this reaction will lead to I3 minus. So the possible answer is 3. It is, how will you name this compound? It's actually a complex of mercury with iodide. You can call it tetraiodo mercurate. Mercury is actually hydrargyrum, but you need not name it as hydrargyrate. You simply name it mercurate. So tetraiodo mercurate with the valency 2. So it will be called tetraiodo mercurate within bracket 2. Okay, so the answer is 3. Now to next question. Question number. It's a question from organic chemistry. You have got very simple question it is. It's a reaction of alkyne. Alkyne is a standard reaction of alkyne with H2SO4 and HgSO4. That means in acidic medium and in presence of the catalyst mercuric sulfate. This can add a molecule of water. So CS3, it can actually add a molecule of water, CS3, C triple bond CH can add a molecule of water. When water is added, of course, Marconico rule is to be obeyed. So H will be there and OH will be there. So the product will be CS3, COH double bond CH2. And that is this one. CH2, CS3COH double bond CH2. But you know, it is a enol, alcohol or ene double bond, enol. And this enol will undergo tautomerism. Tautomerism means shifting of double bond and proton in opposite direction. Enols have the tendency to undergo tautomerism. So here it is a exchange of hydrogen atom and a double bond, and that will give you CS3C double bond to CS3. So your answer will be the last one. It is 4. That way, answer second question, answer 4, based upon organic chemistry. Number 3 is an organic chemistry question based upon definition of electrophile. Very simple question. You know, electrophiles are electron deficient species. They need not be carrying a positive charge. They have electron attracting power, but more important is their electron deficiency. So the answer can be only this one. Electrophile can be either neutral or positively charged. More important part is they will contain electron deficient central atom and can form a bond by accepting a pair of electrons. Why they are accepting a pair of electrons? Because they are electron deficient. So the correct answer will be 4. Example, you know already. Neutral mean a neutral electrophile is CS3 radical, methyl free radical containing 7 electrons. This carbon has got 7 electrons in the valence shell. It is short of 1 electron. It can form a bond again. Also one more CH2 with 2 electrons shown like this. But you call it carbene. You call it carbene. It can, actually it is carbon bonded with a single bond with 2 hydrogen atom, and the remaining 2 electrons are carbon free. But together you have got 2 plus 2 plus 2, 6 electrons only. It is also electron deficient. They are neutral also. Okay. Next question. Number 5. Which of the following pairs of compound isoelectronic? Isoelectronic and isostructural shape of the molecule also should be the same. See, beryllium chloride is linear. XeF2 is also linear, but the problem is they are not isoelectronic. The answer can be this one. We can verify this. Which of the following pairs of compound is isoelectronic and isostructural? The beryllium chloride is actually BeClCl. It is linear. But it is not isostructural with XeF2 because in XeF2 the structure will be corresponding to octahedral shape. Ceylon will be at the center and there are 2 fluorine atoms like this. These points occupied by lone pair. So you cannot consider this as structure. Structurally that is same. It is actually a linear molecule, but the electronic distribution is not the same. It is actually the same for these two. You just simply calculate the number of lone pairs and bond pairs in IBr2 minus. IBr2 minus. How will you calculate? Iodine contains 7 electrons of its own. 2 electron bromine will supply. So that will be plus 2. And 1 electron negative charge. So total 10. So it is 7 plus 3, 10 electron, 5 electron pairs. And what about XeF2? In XeF2 also, XeF2, you simply calculate. In XeF2 you have got 8 electrons of own, xenon 8 electron, 2 electron given by fluorine, total 10, also 5 pairs. So that part is okay. So the electron pair is the same. That is what is meant by isoelectronic. It is not actually counting the total number of electrons found in the electrons are equal. It is only the electron distribution. So 5 pairs, 5 pairs. And what about the shape? IBr2 minus and XeF2 both are having this distribution. Actually 5 electron pairs lead to this particular 5 electron pair will lead to this particular geometrical shape. And the 2 atom fluorine will be here. In xenon will be at the center with electron pair here. And in the case of IBr2 minus, same, iodine will be at the center, 2 bromine will be here, and the remaining pairs will be there. So answer should be 3. That way you find it out. Now question number 6. The species having bond angle 120 degree is. So also very simple. The direct question, BCl3. Because boron is sp2 hybridized and no lone pair around boron. So it is 120 degree, direct question, answer 4. Now question 7, which are the following? Is a sink for carbon monoxide. And the accepted answer is microorganism present in the soil. Many students actually gave hemoglobin as an answer. See, the word sink actually means somewhere you have to deposit the unwanted substances. A sink is acting as a sink when you are using it for discharging the unwanted impurity. You have got, say, wastewater, for example. You throw it to a sink, it will be flowing down there. Nobody is actually keeping hemoglobin exposed for absorbing CO from atmosphere. So it cannot be considered as a sink. The word sink actually means somewhere it can deposit the unwanted thing and that will be taken care of. So hemoglobin can absorb carbon monoxide, but nobody is using it as a sink for collecting the carbon monoxide air. So that is not the relevant answer. This is the answer. Microorganism present in the soil. Next question. 7th one. Which one of the following pairs of species have the same bond order? This is a question from molecular orbital theory. Bond order can be the same when the total number of valence electron is also. See, carbon monoxide and nitric acid, simply calculate. Carbon contains 6 electron, oxygen 8 electron, total 14 electron. The structure will be similar to nitrogen gas. NO will contain N nitrogen 7, oxygen 8, 15. So they cannot have the same bond order. MO structure will not be the same for this. So this is the easiest method. Simply count the number of electrons to be accommodated in the different molecular orbital. So that way if you look at it, Cn minus NCO. Cn minus is 6 plus nitrogen 7 electron plus 1 electron have the negative charge. So total will be 14. And CO also 14. So that also is a simple question. Answer is 3. Next, 8th question. That is a slightly difficult question. I told you there are 3 or 4 difficult questions. This is one among the difficult questions. It is based upon two reactions in organic chemistry. Or you can take it as a single reaction, no problem. Aldol condensation, that is the reaction. So, which is the compound given there? Cyclohexanone. So, this is the point you are starting with. Cyclohexanone is a ketone having a CO in the ring. Cyclohexanone. It contains alpha hydrogen atom. It is CH2 here. Therefore, there is alpha hydrogen atom. Here also there is alpha hydrogen atom. And you know, when such a compound is treated with alkali, alkali will abstract a hydrogen from alpha hydrogen, giving a carbanion. And the carbanion obtained will be this one in this case. This is the carbanion generated. And what happened in the second case? This carbanion now can attack another cyclohexanone molecule. It is here that you have got the second molecule. Naturally, this bond being polar, negative charge will attack this point. And after this attack, electron will be shifted to this oxygen. So here, the next step I can write like this. It is oxygen double bonded. This produces a new bond. You put a line from here and let it come over there. This is the new bond generated. This is the one. And the oxygen will be now connected with a single bond, and that become O minus. Carbanion attacks the alpha carbon. Not alpha carbon, the carbonyl carbon. Carbanion attacks the carbonyl carbon, and that gets added. And from the medium, it will abstract a hydrogen atom, and finally that will make a aldol. Aldol formed is this one. O double bond, a single bond here, and I'll write like this here. It is the same. And at this point, you have got a OH. I just wrote it this manner, that's all. This is what is called aldol. What are aldols? Aldols are, compared to this, aldols are actually beta hydroxy carbonyl compounds. With respect to this carbonyl carbon, this is alpha carbon, this is beta carbon. So it is beta hydroxy carbonyl compound. Then what? They have the tendency to undergo elimination of water. Aldols have the tendency to get dehydrated in acid medium. So simply when you warm it in acid medium, hydrogen of this carbon and this OH will be eliminated as water, giving the final compound double bond O. Then you have got a new bond generated. OH and bond mean a double bond comes over there. This becomes a double bond, and then the ring will be like this. So this is the answer. It is a alpha beta unsaturated carbonyl compound. So the whole thing is only aldol addition followed by dehydration. And this compound is the final product, which is the answer. Therefore, possible answer is the one having a double bond at the center. So 2 will be your answer. Answer is 2. Aldol addition followed by elimination of water. Then, question number 10. Name the gas that can readily decolorize acidified KMnO4. KMnO4 is a very powerful oxidizing agent. So out of this, a possible answer will be this one. SO2 is a very powerful reducing agent. SO2 can easily donate electron to KMnO4, and SO2 itself will be converted to SO3. So this is in aqueous solution that is existing in the form of SO3 2 minus. You know, when SO2 dissolves in water, H2O plus SO2 will become H2SO3. And that gives you this ion sulfite. It is sulfite. Okay. And this sulfite is a reducing agent, and it will accept oxygen from KMnO4, and that will be converted to sulfate in acidic medium. So during this reaction, this S4 plus become S6 plus. Sulfite becomes sulfate. KMnO4 will be reduced back to Mn2 plus. reaction is redox involving potassium permanganate and sulfur dioxide. That's all. Next question. So answer will be 2. 11th question, that also requires some explanation. Which one is a wrong statement? This is something related to atomic structure. de Broglie wavelength given by lambda equal to h by mv, where m is the mass and v is the velocity, that is usually the version. But here they have mentioned group velocity. That is a slightly different. But there is a correction. According to de Broglie, every material particle will have associated waves. Let this be the associated wave. When matter is there and it is moving, it will be associated with a matter wave. Wave motion will be spread from the particle. So, you have got an entity particle here, you can consider this as a particle. But surrounding this particle, there will be waves also. That is the primary concept of wave particle duality. Now you take it as a single unit. That's the easiest method of understanding what is a group velocity. You consider this as a duality, particle wave duality. And in space, this group is moving. Which group is moving? Particle along with the wave is moving. That group is moving with a velocity. Effectively, that is the particle velocity. So, group velocity is actually the particle velocity. So, the first statement is correct. Now, why that is specified as group velocity? There is another velocity which is called phase velocity. That is it. It is another velocity is also there. That is called phase velocity. That is actually the velocity with which these waves are spread in space. It is a wave motion. Matter wave is a wave, and every wave will have a wavelength, frequency and velocity. So if you consider this wave as a separate entity, the waves will have its own velocity, and that velocity is called phase velocity. Because they have mentioned that word group, I am just mentioning the other one. So in de Broglie concept, when you consider the particle and wave together, they are moving in space with a particular velocity. You call it group velocity. But waves themselves will have their own velocity. Every wave has got a velocity related to frequency and wavelength. And that velocity, the wave is called phase velocity. And one more thing I will tell you, this velocity of the particle, it is less than the velocity of light. So you can actually have a relation you can write. Group velocity in general is less than velocity of light c. Sorry, less than. It is actually less than the velocity of light. And also one more thing, the phase velocity is actually more than the velocity of c. That is it. It is the velocity of the matter wave only. That part is greater than the velocity of c. And in fact, there is a relation for any wave particle duality. Group velocity multiplied by phase velocity is equal to c squared. It's an additional point I am giving. That's all. Product of phase velocity and group velocity is equal to c squared. And these two velocities are the same for light wave. Ordinary light, these two are the same. That much about group velocity, phase velocity and the relation. Not important in a way, but because in question paper you are seeing this word group, you can expect more questions on this type. If so, these are the point. One, group mean particle and wave together, moving in space with a velocity called group velocity. But the waves themselves can move with a different velocity. Waves taken separately, considered separately. That velocity will be called phase velocity. Particle cannot move with a velocity more than that of light. So group velocity is always less than that of c. And to compensate as though phase velocity is more than velocity of light. And when you multiply these two together, the relation will be, it should be equal to c squared. Okay, so this is correct. Number 1 is correct. Then you have got uncertainty principle, delta E into delta T. See, it's another uncertain relation. In quantum mechanics, Usually you write the uncertainty relation in the form delta P into delta X greater than or equal to H by 4 pi. Correct. Okay, that is right. But remember, it is not momentum and position alone mutually related by a similar expression. You can have more relations so that H by 4 pi delta P delta. You have got more variable. One such variable is energy of a particle and the time of measurement. Suppose you are measuring the energy of a particle in a certain interval of time. Especially this is applicable to electron undergoing transition in an atom. There is a relation energy of the electron multiplied by the interval during which electron possesses that energy, also related to delta E into delta T, also related to H by 4 pi. Both are actually uncertainty relation, one in terms of momentum and position and the other is in terms of energy and time. This also is a familiar uncertainty relation. But this one you are not actually studying in NCERT, that is because in NCERT they are mentioning time independent Schrodinger equation. You just mention a word Schrodinger equation. What they mention is time independent. Time independent means you need not have this relation there. In general, if an electron has got energy depending on time, in this relation electron is having a momentum or energy depending on the position. But in this relation, energy of the electron is related to the time. Okay. So if energy and time are mutually related, there is uncertainty. When you are sure about the energy of the particle, you are nowhere regarding the time at which that electron possesses that energy. So they are also what is meant by this delta E delta T, the relation between energy and time may be given as they are complementary variable. Position and momentum are complementary variable, meaning when one is certainly known, the other is uncertain. So energy and time are complementary variable. When one is certainly known, the other will be uncertain. Position and momentum also complementary variable. But what about momentum and energy? They are not complementary. You can measure both energy and momentum with accuracy. Position and time also we can measure accurately. It is this way that you write it. So there are pairs of variable which you can measure accurately and you cannot measure accurately. In uncertain relation, such variables are given where one, if you are absolutely sure about the value of one variable, other will be uncertain. In such variables are called complementary variable. So this is such a question. Now third one, half-filled and fully filled orbitals have greater stability. That you know is a very familiar thing. The reason also you know. The energy of 2s orbital is less than the energy of 2p orbital. That is wrong because what is mentioned is hydrogen-like atom. For hydrogen-like atom, you know 2s energy is the same as 2p energy. Energy depends only upon principal quantum number. So last one is wrong. Your answer will be 4. That is a wrong statement. Wrong statement. Now next question, number 11. Correct increasing order for the wavelength of absorption at the visible region in a coordination complex. See, when the ligand is very strong, the splitting energy, crystal field splitting energy also will be very high. When the energy is very high, transition frequency will be very high. So how do you get the answer for this? Suppose you consider a very weak ligand. Weak ligand means this splitting is very small. So the corresponding energy of transition will be very small and the wavelength will be large. That means the weak ligand will have larger lambda value. Weak ligand means splitting will be very small. So transition becomes easier. Easier to the transition means energy involved is small. So wavelength will be large. So here you have to arrange them. What is the increasing order of wavelength? That means decreasing order of energy. Increasing order of wavelength means decreasing order of energy. Decreasing order of energy means weak ligand first. Water is a very weak ligand. Then comes ammonia. So the possible answer will be 3. First water, or will it be the first one? You want increasing order of wavelength. That means decreasing order of energy. See the word. It is not mentioned whether it is greater than, less than, or here. Here you have got the weakest ligand first. Weakest ligand means maximum wavelength. Maximum wavelength comes over there. So it is maximum here, less than value here, least value here. So it is decreasing order. We want increasing order mean answer can be only 1. En is the strongest ligand. So maximum width, maximum energy, so small wavelength. So minimum wavelength here, next comes ammonia and the maximum wavelength for water. So answer is 1. Don't have a mistake 1 and 3. One is increasing order, the other is decreasing order. So answer is 1. Next 13. Correct order of stoichiometries of AgCl formed when. That also somewhat simple. See, in a coordination complex mentioned here, you are given COCl3, cobalt, as you know, generally forms a octahedral complex. So in the first, you are given the formula COCl3 6NH3, first one. In this case, you know, ammonia is a stronger ligand compared to chloride. Ammonia stronger than chloride. So in this complex, structure should be cobalt surrounded by ammonia, 6 ammonia molecule, and chlorine will be outside. I cannot actually write ammonia outside and chlorine inside because stronger ligands will be inside the coordination sphere and weaker one will be the counter ion. So first one will have 3 chlorine outside the coordination sphere mean all the 3 can be precipitated. So 3 in first one. But second one only 5 ammonia. So naturally 1 chlorine will be inside. The remaining 2 only will be precipitated. So first one 3 chlorine precipitated, second one only 2, and the last one contain 4 ammonia only. So 2 chlorine will be inside, only 1 counter ion chloride outside mean in this order. First compound will have 3 precipitate AgCl, second will have 2, and the last one 1. That way it goes. So what will be your answer? 3, 2 and 1 mean 3. That way it goes. So it depends upon the structure of the complex. Remember, ammonia is a stronger ligand, chloride is a weaker ligand. So as far as possible, ammonia will be inside. And if there is a vacancy for octahedral complex, chloride will be inside. And that chloride cannot be precipitated. Only counter ion can be precipitated. Now 14. Question from organic chemistry. Which one is the most acidic compound? It's a question on phenol actually. And obviously this is the answer. You know why? 4 is the answer because when you know electron withdrawing group attached to benzene ring will make phenol more acidic. Electron withdrawing group attached to benzene ring will make it more acidic. So the 3 nitro groups are there. 1, 2 and 3 nitro groups are there. And you know that is picric acid. It is the strongest out of the 4. Methyl attachment will make it weaker. Electron donating group will make phenol weaker. The CH3 will make the phenol weaker. NO2 will make it stronger, but here you have got 3 NO2. So naturally the strongest acid is 4. The answer is 4. Very simple one. Next question, number 14. Correct increasing order the base strength of amines. It is exactly the opposite of phenol. When you are attaching a electron donating group as in this compound, electron donating will give push electron towards the amino group. So that will be more basic. Electron withdrawing group will withdraw electron from lone pair, this part. So that will be the weakest one. So the strongest amine will be this one 3. Weakest one will be this one. And in between there will be amine. So what is the possibility? want to see the symbol written there. 2 less than 3 less than 1 mean 2 basic character is less than, 2 is less than 3. That is right, but it is not less than 1. So that cannot be there. What about this one? 3 less than 1. 3 means this compound. Weaker than 1, aniline. And aniline weaker than nitroaniline. Is it correct? It is actually 3 means this compound. It is pushing electron towards. That means it is the strongest one. So it is not less than. So that also is not the answer. So the answer, what about this one? The last one. 2 less than. 2 means this compound. Nitro withdrawing electron, least basic compared to this. So your answer will be 4. Remember the point is electron withdrawing makes a amine weaker. Electron donation makes an amine stronger. That's all the point. Then next question is, which pairs of ion will have both species contain S-Sbond? S-Sbond is present. You have to study the structure. Out of this, S2O7 minus is occurring everywhere. S2O7. So if see, it's a simple method. S2O7 occurs in 1 option, 3rd option and 4th option. If that is the answer, normally if it contain S2O7, you know what is it? S2O7 is called oleum. It is called oleum. And in oleum, there is a oxygen atom shared by a sulfur atom. One oxygen common, the other will be SO3H. And this will be SO3H. This is what is called oleum. Okay. Originally, you can consider this as sulfuric acid. SO3H, OH is sulfuric acid. See that H2SO4. Okay. So here, if you introduce one more SO3, you are getting this compound. So this is not having a S-Bond. S-Bond is no absent. So here, what you want is both species contain S-Bond, mean S2O7 cannot be anywhere the answer. So this cannot be the answer, this cannot be the answer, this also cannot be the answer. Possible answer is 2, correct. See the structure, S2O6. What is this? S4O6, 2 minor. S4O6 is actually called a tetrathionate. It's a product obtained when thiosulfate reacts with iodine. And the structure will be a long chain of sulfur atom, 1, 2, 3, 4. And here, there will be oxygen minus 1, oxygen minus 2. So out of the 6 oxygen, 2 occurs as O minus. Then you have got oxygen, oxygen, oxygen and oxygen. That is what is called tetrathionate. If the number of sulfur is reduced, you get trithionate. It will be S3O6, 2 minus. So in all thionates, maybe dithionate, trithionate, tetrathionate like this. There is a chain of sulfur atom and the terminal sulfur atom will be occurring as SO3 minus. So this contains SS linkage. And what about thiosulfate? Thiosulfate is only a just modified structure of sulfate. Sulfate, as you know, is SO minus, double bond O, double bond O. Here, if you replace one oxygen with sulfur, that is thiosulfate. If you replace one oxygen from sulfate with sulfur, you are getting thiosulfate. So here also there is a SS linkage. So thiosulfate and tetrathionate will be the answer. Answer 2. The other one is called, it is oleum. Okay. So next one, 17 question, mixture of chloroxylenol and terpineol acts as, you know, it is a antiseptic. It is an antiseptic. It is given in NCERT, chemistry in everyday life. 18 question. That also is simply taken from first year organic chemistry. You know, acetylene is acidic. You have to arrange them, correct order of acidity. Most acidic will be this one. CH, triple bond CH, most acidic. Generally, alkynes are more acidic than alkene. Alkenes are more acidic than alkane. So order will be alkyne first. But if you compare this alkyne with a substituted alkyne like propine. Propine is less acidic than alkyl. So what is the answer? Most acidic will be CH triple bond CH. Then comes this one, CH3, C triple bond CH. Then come alkene and finally alkane. So your answer should be 2. No new principle, only old one. Terminal alkanes are acidic. And among the alkyne, acetylene is the most acidic. 19th question. The heating of phenyl-methyl ethers. Phenyl-methyl ether is C6H5. OCS3 phenyl-methyl ether. What is that peculiarity? HI can decompose ethers. There the first step is protonation of ether. This is protonated ether. C6H5 OCS3 phenyl-methyl ether. And when it reacts with HI, first of all it gets protonated. Protonation of ether takes place with oxygen giving protonated ether. Next it will be iodide can act as a nucleophile, attacking nucleophile. Iodide can attack either here or iodide can attack here. But remember, this attack cannot lead to a product because this bond is stronger. Oxygen attached to a phenyl ring is stronger than oxygen attached to simple carbon. So this attack will not give any result. Therefore, what happens is this attack will work and the electron will be migrating towards oxygen giving phenol. This part becomes C6H5OH and this becomes CH3I. So the possible answer is only methyl, iodide and phenol, of which phenol is given as the answer. So answer is 3. It all depends upon the easiness of cleavage of carbon-oxygen bond. Aromatic ring attached to oxygen, that bond is very strong compared to oxygen attached to a carbon on alkane. Next question. A gas is allowed to expand. During expansion of a gas, work will be done. And the formula for work done will be W equal to minus P external delta V. That is the formula for work done. You can use it here because what is given is a gas is given. It is expanding against a constant pressure. It is this external pressure, that is 2.5. So work will be minus 2.5. No, what is the pressure against which it is expanding? It is given as container against a constant external pressure of 2.5 atmosphere. It is this 2.5 that is acting as the external pressure. Now delta V will be final volume minus initial volume. Final volume is 4.5 liter. Initial volume is 2.5 liter. So pressure into volume increase or decrease. Therefore the answer will be minus 2.5 into 2, which is minus 5 liter atmosphere. But options are given in joules. So conversion factor, 1 liter atmosphere is equal to 101 joules. So simply multiply with 101, you are getting the answer 505. With a minus sign, the answer will be 3. Remember, this formula as such you can use only for calculating work done in irreversible expansion. If it is reversible, formula will be RT log V2 by V1. So how do you know that this is the formula to be applied? This is the formula to be applied because it is specifically given that the gas is expanding against a constant external pressure. Expansion against a constant external pressure is always irreversible. If it was in reversible expansion, remember the external pressure and the pressure of the gas should be only infinitesimally different. So throughout the expansion process, if this condition is being satisfied, external pressure has to vary in infinitesimal stages. So external pressure cannot be constant. So simply in this problem it is given external pressure is a constant value, mean it is irreversible. So apply this simple formula. The answer therefore is 3. Question number. Next one. Most suitable method of separation of 1:1 mixture of ortho and para-nitrophenol. The standard question for NCERT. Steam distillation is the answer. Ortho nitrophenol. and para-nitrophenol, this mixture. Remember, this is the point. This mixture can be separated easily by steam distillation method, because in presence of steam, this will distill out. Along with the steam, this can boil out. That property is called steam volatility. It is steam volatile. Along with steam, it will volatilize. This will not go out. That is the answer, therefore. This can be separated from non-steam volatile impurity by steam distillation method. So the answer is, which are the other compounds generally separated, purified by steam distillation? They are aniline. One is aniline, second is ortho-nitrophenol, and the third is nitrobenzene. Sometimes these will be given as option and the answer will be all the above. Usually ortho-nitrophenol, aniline and nitrobenzene, they are purified by steam distillation method. So if 1, 2, 3 options are the answer will be definitely all the above. Question next one. With respect to the conformers of ethane, it's a tricky question actually. See, the conformers of ethane, you are drawing like this. This is one method, hydrogen, hydrogen, hydrogen. Then you can have hydrogen here and hydrogen here. This is what is called the staggered conformation. And if you want to draw the click conformation, this hydrogen will be coming just behind this hydrogen and will be indicated somewhere there. It will be this one. You know that. If these hydrogen atoms are the hydrogen atoms on the front side carbon, the right side carbon will have hydrogen just opposite to this. So that will be indicated somewhat like this. Just to show that this hydrogen is behind this one. And this is called eclipse conformation. And the question is, conformers will have the change. The answer directly will give you. Both bond angles and bond length remain the same. Suppose I rotate this molecule to obtain this structure, bond angle will not change. 120 remains 120. Bond length will not be affected. But what will be affected is an angle like this. This angle will be affected. In this structure, for example, this angle is theta. But in this structure, this angle is 0. What is that angle called? It is called dihedral angle. It is called dihedral angle. So when you have comparison between eclipse and the staggered conformations of ethane, they differ in dihedral angle, not bond angle. Here it is given as bond angle and bond length. They will not change, so the answer will be 4. What changes will be? Dihedral angle. It is a simple question, but remember that word. Next, 23. It's also a very good question. Very good question it is. One principle about equilibrium, chemical equilibrium. See the reaction mentioned here. Let's directly go to the question. There is an equilibrium between solid SrCO3. They purposefully change it to strontium carbonate because we are generally doing it using calcium carbonate. They change it to strontium, that's all. But in principle, no much change. SrCO3 equilibrium with SRO gas, solid plus carbon dioxide gas, correct. Now regarding this equilibrium, one thing given is, if you allow the system to attain equilibrium, there will be an equilibrium constant K given by concentration of SRO solid into concentration of carbon dioxide divided by concentration of strontium carbonate, active mass. And the active mass of solids will be 1. So this is 1, this is 1. So effectively it is the active mass of carbon dioxide. If you express this as Kp, this carbon dioxide concentration is expressed as partial pressure of carbon dioxide. So if there is an equilibrium, the partial pressure of carbon dioxide should be a constant. And what is given is, this Kp will be equal to, what is that value given? It is given as 1.6 atmosphere, I think. It is given as 1.6 atmosphere. How do you know that? 20 liter, 400 Kelvin, CO2 gas, pressure 0.4, etc. is given. And what is given finally will be Kp will be equal to 1.6 atmosphere. What do you mean by this? If you have, this is the reaction vessel taken. If this is the reaction vessel, and here you have got SRO, SrCO3 and carbon dioxide. If there is to be equilibrium as shown in the equation, this pressure should be 1.6 atmosphere. Now what will happen if I am increasing this pressure beyond 1.6? I compress this gas using the piston to say 2 atmosphere. Naturally, excess 0.4 atmosphere pressure will be reduced by backward reaction. Backward reaction will occur. But in this problem, what is given is, initially we start the reaction taking only 0.4 atmosphere pressure of carbon dioxide. See, the vessel contains only 0.4 atmosphere carbon dioxide. If equilibrium is to be there, there should be minimum 1.6 atmosphere. So there is no equilibrium here. Equilibrium means there should be 1.6. We have taken only very negligible amount. What we have taken is only negligible amount. So vessel is here, but the volume of the gas is so high that the total pressure is only 0.4 atmosphere. So there is no equilibrium. But still it can excess because gas cannot go here. So gas, see, remember this thing, gas cannot spontaneously come over this volume, it cannot reduce and make the pressure 1.6. Because the tendency of the gas will be to spread throughout the space provided. See, if you are providing this much volume, the whole gas will spread in that direction and its pressure will be 0.4, no equilibrium. So if you try to increase this, suppose I am increasing the reducing the volume to 50%, this pressure now become 0.8. Still there is no equilibrium. Pressure become 0.8, that's all. Equilibrium cannot be there, it should be 1.6. Now again I am reducing this to 1/4 the volume. Now the pressure become 1.6 atmosphere. So what I see is, if I increase the pressure, decrease the volume continuously, you can see pressure goes on increasing from 0.4, 0.5, 0.6, 0.9, 1, etc. Nothing will happen because reaction is not in equilibrium. But when it becomes 1.6, it is the equilibrium value. So up to 1.6, I am continuously decrease the pressure, decrease the volume. To that pressure, you can increase the pressure. You can apply pressure, you can reduce the volume of the vessel and bring the volume to how much? Till the pressure is 1.6. So effectively, what is the question? You have got carbon dioxide initially at a pressure of 0.4 atmosphere. To what pressure you can decrease the volume? So that maximum pressure obtained will be there. So you can actually decrease the volume to 1/4 so that this pressure become 1.6. Then after, if you decrease the volume, what will happen? Pressure becomes safer. So more than 1.8, 1.6. Naturally backward reaction will occur and the pressure will be maintained at 1.6. Question is, to what pressure? What is that? The volume of the container is now decreased by moving the piston downward. So what condition? Movable piston fitted container, the maximum volume of the container when pressure of carbon dioxide attains its maximum value. Pressure of carbon dioxide attains the maximum value is 1.6 atmosphere. You cannot increase the pressure beyond 1.6 because beyond 1.6 system will behave as per the Lee-Shadley principle. Up to this there is no equilibrium, so you can continuously decrease the volume. So the maximum volume change you can expect is up to a volume where pressure become 1.6. Initial volume is 20. So when the pressure become 1.6 means the volume should be reduced to 1/4. So volume at that stage will be 5 liter. It is therefore this is the answer. Up to 5 liter you can continuously decrease the volume. Gradually pressure will increase. But if I again reduce the volume to beyond 5, suppose it is 5 liter, 4 liter, then pressure goes above 1.6. But that pressure immediately will be neutralized by moving of the system in backward direction. That way your answer is this one. So it is a question based upon equilibrium chapter. And also one more thing, Lee-Hartley principle works only when the system is in equilibrium. In this case, there is no initial equilibrium. You simply apply the PV law. Volume 20 liter, pressure 0.4. Then what is the volume when pressure is to become 1.6? So 1/4 volume, that is 5 liter. It's a conceptual question. Very good one. 24. A first order reaction has a specific reaction rate 10 raised to minus 2, second minus 1. How much time will it take for the reactant to reduce to 5 gram? As such, one part is very simple. You start with, it has got a initial amount 20 gram has to be reduced to 5 gram mean, because it is first order, 20 becomes 10 in first half-life period, 10 become 5 in second half-life period. So this is T half, this is T half. The total time required is 2 T half. That part is okay. Now what is the T half of the reaction? What is given is specific rate constant, but T half equal to 0.693 divided by K. T half is 0.693 by K mean 0.693 divided by 10 raised to minus 2, which is 69.3. This 10 raised to minus 2 in the denominator will make it 69.3 second. So 2 T half means 69.3 into 2, 138.6 second. So that will be your answer, 138.6 second. Answer 2 kinetics. Very simple question. Nothing else. 25. For a given reaction, delta H equal to 35.5, delta S equal to 83.6, and what condition is, under what temperature condition it will become spontaneous. Means what? You have to apply the relation delta G equal to delta H minus T delta S. This is the condition. So this is the relation called gives Helmholtz equation. You can use it for predicting feasibility of a reaction. In this question, you have to ask to calculate the temperature above which reaction becomes spontaneous. So first you calculate the temperature at which reaction will be in equilibrium. What you actually want is the temperature above which it becomes spontaneous. But you calculate the temperature at which it will be in equilibrium first. At equilibrium, this is 0. So let the condition be equilibrium. So 0 equal to delta H minus T delta S. Therefore, T equal to delta H divided by delta S. Bring this term to the left side, divide. And these two values are given to you. Delta H is 35.5 kJ, 35.5 kilojoule. I am converting this into joule. 35.5 into 1000 joule divided by delta is expressed in joule 83.6, and that will work out to 424.6 Kelvin. That means at this temperature it will be in equilibrium. So naturally at temperature slightly above this it will be spontaneous. So naturally the answer will be 425. Temperature should be greater than 425 Kelvin. So the answer will be 1. Thermodynamics simple question possible. 26. The electrochemistry question. There is a cell prepared from zinc and zinc sulfate. Zinc sulfate, salt bridge, copper sulfate, copper. For this question, you can have various types of question here, but here you are changing the concentration of copper sulfate and zinc sulfate, and you are asked to predict what will happen to the EMF. A simple method of getting an answer for the question is, you write down the cell reaction first. You need not write down the Nernst equation, simply write down the cell reaction. In this case the cell reaction will be zinc will dissolve in copper sulfate, displacing copper metal, and solution will contain zinc sulfate. That is it. Zinc being more active metal will displace copper. Now remember one point. Whatever you do in this reaction, which will favor forward reaction, all this will result in increase in EMF. Simply, you consider conditions under which forward reaction will be favored. Simply apply the Lee-Chatry principle. Whatever you can do, you do it. But remember, if what you do is favors the forward reaction, EMF will be increased. If whatever you do decrease the rate of forward reaction, it favors the backward reaction, EMF will be decreased. See what is done there. In this case, you are given zinc sulfate originally is 0.01 molar and copper sulfate is 1.1 molar, 1.0 molar. But next what you do is zinc sulfate concentration increases to 1. This is made 1 molar, but zinc sulfate is the product side. You are increasing the concentration of the product. Increase in the concentration of product means backward reaction will be favored. Increasing zinc concentration means because zinc concentration is on the right side. Increasing the concentration of zinc sulfate means backward reaction will be favored. You are not actually favoring forward. So that will result in decrease in EMF. And next is increase in the copper sulfate originally is 1 molar, but it is decreased to 0.01. That also will result in decrease in EMF because copper sulfate is reactant. So you are decreasing the concentration of reactant and increase in the concentration of product mean overall effect is backward reaction will be favored. So voltage will be reduced. So naturally second voltage E2 will be less than E1. So the point is this one. Whatever you do on the reaction which will result in backward reaction, it results in decrease in EMF. Okay. So here the answer should be if you do this, voltage is reduced. So what is the applicable answer? E1 greater than E2. So answer will be 3. That is it. Then example of a sigma bonded organometallic compound is you studied I think ferrocene having the formula FeC5H5 twice. And the structure of this compound is something like this. It is cyclopentadienide anion. Cyclopentadiene, from which one hydrogen is gone, anion part is there. One more cyclopentadienide anion. And in between there is a ferrous. It is said to be a compound formed by sandwich method. First there is a layer of cyclopentadienide. This is aromatic. This is another cyclopentadienide. And in between there is a positive charge iron. Iron being positive and these two anions are negative, so they will be attracted. It will form a salt. But the electrostatic type of attraction. But the next bonding is very important. The pi electron cloud of this aromatic ring will overlap with the d orbital iron. Similarly, pi electron cloud of this ring also will overlap. It is the pi electron cloud that is taking part in bonding. Therefore, this is called a pi bonded complex. That bond will be indicated like this. You draw lines from all the corner to iron. Like this you draw. That's all. What is shown here is pi bond formed between the d orbital of iron and the pi electron cloud of that aromatic ring. So ferrocene is a pi bonded complex. Next, exactly similarly, you have got ruthenocene. Iron replaced by ruthenium, that's all, Ru2+. Similarly, what is the next one? Cobaltocene. Iron replaced by cobalt 2+. All are similar. They are all pi bonded complex. But what about Grignard reagent? It is CS3MgBr. In this case, there is a sigma bond between carbon of methyl and magnesium. Sigma bond. So it is called a sigma bonded complex. So generally, remember, Generally, you got Grignard reagent, an organometallic compound formed by this type of method. It is called a sigma bonded complex. Another example will be lead tetraethyl. Lead tetraethyl, lead at the center, then you got 4 ethyl groups, C2H5 4 times. It's a sigma bonded complex. Next question will be equilibrium constant of the following. It is a question taken from, again, ionic equilibrium. The easiest method of getting the answer will be just by examining. Sometimes you can easily get the answer. See this option. Final equation has got 2NS3 on the left side. 2NS3 on the left side. It is here that you have got NS3 and 2NS3 on the right side. If it is on the right side, K will be written as K equal to NS3 whole square divided by. So if it is written like this, you have got K1 in the numerator. If you reverse this, K1 will be in the denominator. NS3 on the left side. Here you have got NS3 on the right side. 2NS3, 2NS3. So K1 should be occurring in the final equation in the denominator. So your answer can be either this one or this one. It's an easy method. Then you have got the next one. N2 plus O2, 2NO. Where is the 2NO now? In the final equation, 2NO is on the right side. 2NO is right side means K2 should be on the numerator. K2 numerator, this can be correct, this also can be correct. Both are possible. But here it is K2, here it is K2 cube. K2 cube will occur only when this is multiplied with 3. So normally the expected answer is this one. And what about K3 then? Automatically the answer will be 3. Here you got water on the right side. It is K3 here. But you have to examine whether K3 here. So just verify whether this is correct or this. This may be correct, but we will verify this. The method will be, try to get this unknown equation by proper addition. So start. 2NS3 should be on the left side, mean you write it as 2NS3 giving the actual method. 2NS3 giving N2 plus 3H2. So K will be, for this equation, will be 1 by K1 because you have written the equation in the reverse order. Now 2NO you require on the right side itself. So second equation I will write like this. N2 plus O2 will give 2NO and the corresponding K, let it be K2. Now the next will be water should be on the right side, but there are 3 molecules of water coming up. Here you have got only 1 molecule. So that indicates third equation should be multiplied with 3 and then written. So I write 3H2 plus 3 by 2 O2 giving 3H2O, and multiplication with 3 will give a corresponding K, which is K3 cube. It should be K3 cube. Now you add up and see whether by addition you will be getting this equation. You will be getting that equation and the overall K will be the product of this, which leads to 1 by K1 into K2 into K3 cube. So your answer will be this one. That way you get it. Suppose you have got, because you have got K3 here and K3 here, there may be a doubt. Suppose only in one option K3 is on the numerator, you need not even work out this. That is one method. Sometimes in given option only one will be there, where K1 is in the denominator and K3 will be the numerator. In that case you need not work it out directly out. Because we have got 2 cases where these conditions are met. You have to work it out like this. Overall K will correspond to answer 4, right. Next question will be element set 114. Very simple question from periodic classification. 114 will be, you know that element is flerovium with the symbol FL, flerovium. Anyway, for this element the easy method will be, you subtract 100 out of this, you get 14. So it should be an element of 14th group. 14th group means carbon family. Carbon family members will have configuration corresponding to S2P2. So answer is 2. So it is simple. Element is flerovium. Answer is 2. Then next question. Yes. 30th question. Pick out the correct statement with respect to Mn, C and 6 time. Say complex of manganese with a cyanide ligand. Again very simple. Mn. Cn 6 time. 3 minus means you have to apply the VB theory of chemical bonding in complexes. In this case, you know, manganese is in +3 states. Then only net 3 minus can be there. Manganese being the 25th element will have the configuration 3d5, 4s2, manganese 25. Then manganese +3 will have the configuration Mn will have 3d, 2 electron from S, 1 electron from N. So it will be 3d4 and 4s0. So what is the possible hybridization? Cyanide being a very strong ligand can cause forced pairing in d orbital. So in d orbital, forced pairing is possible. Originally, this is the configuration. Cyanide can cause forced pairing, means this can be introduced into this orbital, taking d2 orbital free. 2 orbitals are now free in 3d. Then of course it will be followed by d2, 4s and next 4p. So configuration will be corresponding to d2sp3 hybridization, d2sp3, this one. It will be octahedral. So answer is 3. It cannot be sp3d2. You know what it is? sp3d2 means 3d is not available due to some reason. And the molecule is formed by hybridization taking 4d orbital. That is what is called outer D. Here it is 3D is available. So no problem. You can actually have D2sp3 hybridization. So the answer will be 3. Now 31. Identify A and predict the type of reaction. It is the most difficult question out of this. Most difficult question. Anyway, this is the answer. Probably some of you have heard about what is called Benzene mechanism. You have heard about what is called Benzene mechanism. This question is based upon this. Let's start like this. When you have this compound, a bromine, for example here, it is aromatic compound, bromobenzene, treated with sodamide, you will get a compound with the formula NH2. But as such, if this is the reaction, it should be a substitution. But the mechanism of the reaction is not simple substitution. It is actually elimination followed by addition. You know how? Mechanism given is, in this reaction, there is a hydrogen here, bromine and adjacent hydrogen. NH2 minus will attack this hydrogen first, abstract the hydrogen, and ammonia will be eliminated. So what will happen then? Initially, this compound is aromatic, and let the bond be like this. Let this be the original bond. When HNBr, when this is eliminated, what will happen then? When this is eliminated, NH2 minus abstract the proton, there is a negative charge coming over there, and that negative charge will be transferred to this to make a triple bond, and then bromine will be eliminated. So the bond formed is a benzene ring, but with a different, there is a triple bond there. Such a species is called benzene. This is called benzene. Benzene means not very stable, but that is intermediate in the reaction. HBr is subtracted. You can consider this NaNH2 as a powerful base. Base can abstract a proton. After abstraction of proton, electron will come over this bond and then bromide can be eliminated. And then comes the next reaction. There is an ammonia gone. Solution contains ammonia also. Then ammonia will be added to this triple bond. First of all, ammonia will be added here. Then bond will be accumulated there, giving a molecule with the formula 1, 2. Then this will become double bond with a minus charge accumulated and NH2 there. But actually, when ammonia supplies this electron, it becomes NH3 plus. And NH3 plus leaves a proton, and that proton will be added there, making the compound aniline. So this is the mechanism. This is aniline. This mechanism is called benzene mechanism. It abstracts HBr and ammonia is added. So the correct option should be, it is a elimination addition reaction. It is a elimination addition reaction. That is point number 1. Now number 2 is, look at this molecule. You look at this molecule. The triple bonded species is benzene. Triple bonded species is benzene. I am initially putting this ammonia at this point. Both points are equivalent. Therefore, why I cannot put a ammonia attack there, making this structure possible? Ammonia can attack either this point or this point. If that is happening, the product obtained will be double bond, NH2 will be there, and this will be negative, which will abstract take a proton, giving this molecule. So in the triple bonded species, NH2 can be added either here or here. Now see these two. In this molecule, NH2 is attached to the same carbon where there was originally a bromine. Originally the bromine was on this carbon, and the final product, it is there, that NH2 is there. If bromine is replaced by the NH2 at the same carbon, that word is called, there is a word given in that option. Somewhere you can see one word. There is and elimination addition. Actually, it is elimination addition. In this option, see the word Sini substitution. Sini substitution. There are two words. One is called Sini substitution, Sini, and the other is called ipso, IPSO. What do you mean by this? In this reaction, if amino group is set as the same carbon, where originally there was a bromine, you call it ipso substitution. But in this compound, it is on the adjacent carbon, and that is what is called Sini substitution. So that is the word Sini mentioned there. Ipso is not actually mentioned. So what are the point? In haloalkanes, and not alkane, haloarine, soda amide reaction will give aniline type of compound, but it is not usually substitution. Elimination followed by addition. Now if the added substance NH2 group is on the same carbon where originally there was a halogen, you call it ipso substitution. If it is on adjacent carbon, you call it Sini substitution. Now you come to the actual question. In the question you have got an OCS3 there. There is a OCS3 that will have definitely an effect. And the effect is, in presence of this, if the suppose there is a CS3, OCS3 there, attack on this carbon is slightly difficult. You can take it as because of steric hindrance. That is an easier method. Presence of this group will make attack on this carbon slightly difficult. So it will prefer attack on this carbon, mean NH2 will be preferably on this. That is why this is the answer taken. Your answer is actually OCS3 at the beta position NH2. So what is the remaining? Actual answer should be therefore, it is elimination addition. And also it's NH2 is not on the carbon where originally there was a bromine. So it is Sini substitution, it is elimination addition. The actual option should be Sini substitution. This is the answer. The Sini substitution, and also it is actually consisting of elimination followed by addition. But such an option is not given. So out of the 4 options given, you are taking this as the answer. It's a compromise answer. Elimination addition is okay, but this is not the product obtained. Therefore, you are going to this option. Slight mistake actually. It should be given here. The NS2 elimination okay. Here also should be given as elimination addition. Correct answer is, it is actually Sini substitution. NS2 comes over a carbon where there was no original bromine. And also it is elimination followed by addition. If you are not going to the mechanism, it is simply substitution. That thing, benzene actually, it is slightly out of syllabus. Anyway, because the question is here, I gave you this much point. Now question 32. Very simple one regarding SN2 plus, stannous and PB. It's a very simple one. SN2 plus you know is a reducing agent. PB4 plus, what is given is PB2 plus. SN2 plus is reducing while PB4 plus is oxidizing. That is correct. You are familiar with the PbO2, for example, lead dioxide is an oxidizing agent. It occurs in very many cases. In lead acid battery also this is having. So this is oxidizing agent, SN2 plus is a reducing agent. But suppose you are asked a question, why PB4 plus is an oxidizing agent? There is an answer. Lead is having inert pair effect. So lead does not have a tendency to part with all the 4 valence electron. So as far as possible, it will try to attain PB2 plus configuration. This is more stable. So it will accept 2 electrons, so acts as a oxidizing agent. PB4 plus acts as an oxidizing agent because lead has got inert pair effect, that's all. But SN2 plus not having that effect, maximum valency will be SN4 plus, oxidizing agent. 33. Which of the following statement is not correct? Let's say biochemistry, also from chemistry in everyday life. You know what it is. Denaturation makes protein more active is wrong. Denaturation makes protein inactive actually. So answer is 4. Which is the incorrect statement? Incorrect is very simple question it is. Frankel defect is favored in those ionic compound in which Frankel defect means displacement of cation in the lattice from the normal point. So cation should be very small compared to anion. But what is given is equal size. Size of cation and anion almost equal is wrong. Cation should be smaller. So this is the answer, wrong statement. 35 will be. There also there is a modification is possible. But out of the given choices, what can be the correct one? You know, CHO is the primary functional group, CHO. Then comes CO. Then you got CH3. Then again CO. CHO, oh sorry, it is not this compound. CHO together, this one bond. Now you got CH3. Then again CO. Then CH double bond CH3. I'd always suggest you write this structure like this. Don't use that structure containing bond line notation for naming. Very often you may be going wrone. Out of this is the principal group. So 1, 2, 3, 4, 5 and 6. So the answer is hex3ene or hex4ene. It is hex4ene. If there is only one answer where you got hex3, if this is the way you name it, 1, 2, 3, 4, 5, 6, it should be hex4, that should be. Double bond should be indicated by 4. See whether such an option is there. Ending will be according to this one. Because it is aldehyde, it will be hexaphorenol. Correct. So the answer can be either one or which one? Maybe more. Aldehyde should be named al. So the correct name should be, there is a group 2-methyl. There should be a group 2-methyl. This actually should be called 3-oxo. Okay, so in that case, methyl comes first, then comes ethyl. So correct name will be 2-methyl, 3-oxo, hexaphorenol. 2-methyl, 3-oxo, hexaphorenol. But that is not given there. They are naming this as keto. It is actually a compromise. Modern method will be, this should be indicated by oxo. You can see in NCERT book. NCERT book, they are naming ketones of this type as oxo. So 3-oxo is the better naming. So what can be the answer? If it is keto, there is a problem will be K occurs in front of methyl. So name becomes 3-keto, 2-methyl, followed by hexaphorenol. That is how we are getting the answer 1. So only out of the 4, only you can take this one. Correct name will be this one. 2-methyl, 3-oxo, hexaphorenol. 36. Reason for greater range of oxidation state. Definitely it is because inner shells are take part in reaction. In chemical reaction, inner shells also will take part, mean 5F, 6D and 7S levels will take part. So it is 3. They are having very low difference in energy. 37. Extraction of gold and silver. Again very simple. Final step is adding zinc metal to displace gold. 38. Ionic probability of which of the following alkali metal ion lowest when aqueous solution of the salt or lithium. Due to heavy hydration, lithium mobility will be least one. 39. Which of the following depends on temperature? Molarity. That also a very simple one. Number 2. 40. Molality of a dilute solution doubled. What will happen to the molal depression constant? A tricky question. Molal depression constant is a constant. What will be the concentration? So remain the same, unchanged. 4 is the answer. 41. Here also some calculation. Here, rate of reaction is actually written according to the slowest step. So I write rate equal to K constant into X into Y2. This is the way you write the equation. Rate equal to K into X into Y2. Then, in the final rate equation, intermediate should not occur. X is a intermediate. So that should be eliminated. For that, you are taking this one. Because it is fast, you can assume equilibrium will be existing between reactant and product very easily. So for this reaction, even if it is not indicated as equilibrium, you assume it is equilibrium. Otherwise, you cannot do. So from the first equation, capital K equilibrium constant equal to X into X, that is X squared, divided by X2. That means final equation X squared divided by X2 is the equilibrium constant K. So concentration of X will be equal to multiply capital K with X2 and then find the square root. What do you mean by this? You write down the expression for equilibrium constant and from that expression evaluate the value of X. It will be root of K into X2 and substitute here. So this equation becomes rate constant K, proportionality constant K into X will be replaced by this, mean K raised to half, X2 raised to half, followed by this X. It will be again X2. This final expression shows the power will be 1.5. So it is 1.5. So there is a slight mistake in the question where they should have given you a reversible arrow there. Reversible arrow they should give. That's all. This equation does not have any effect because this concentration does not come over there. Similarly, they should not actually give this reversibility here. The correct wording should be x2 reversible arrow x plus x. Second equation should have been x plus y2 giving xy slow, xy plus y. This should be the method. That is, it is here that the reversibility should be indicated. It is not here. Reversible arrow here and this other arrow here. There is a mistake in the problem. That's all. Anyway, your answer will be 1.5. 42. Concentration of silver ion. Concentration of silver ion. How will you proceed? You know, silver oxalate or silver chromate, whatever it is. In this case, it is oxalate. Ag2C2O4 in solution will be in equilibrium as 2Ag plus and C2O4 2 minus. This is the way it dissociates. So what is Ksp for this salt? This salt has got Ksp expression, Ksp equal to 4s cubed. Because it is a salt of the type calcium fluoride 2:1. And therefore 4s cubed should be evaluated. So what will you do? You have to calculate the solubility. What they have given is Ag plus concentration is 2.2 into 10 raised to minus 4. It is the concentration of silver mean half the concentration of silver is the solubility S. 2 silver ion divided by 2 will be concentration because every mole of this oxalate will give 2 silver. So silver concentration divided by 2 will be concentration of the dissolved salt. So solubility will be half of this mean 1.1 10 raised to minus 4. Half of 2.2 10 raised to minus 4. So this is solubility yes. So what can be Ksp equal to? Ksp equal to this one 4 into s cubed 1.1 10 raised to minus 4 whole cube. You work it out and you get the answer 4. This will be 4.4, sorry. So it will be 1.1 into 10 raised to minus 4 whole cube. So I have to cube this 1.1, then multiply with 4. So your answer will be 4. That way you get it. Next question, 43 will be column. XX is actually a molecule of the type ClF. It cannot be any other type, it will be linear. So this will match to linearity. This is similar to ClF3 tree shape. So this will go over there. That means A3 B1 should be the method. A3 B1. You have got A3 B1 only here. So that should be your answer. All compounds are familiar to you. A3 B1 2 is the answer. 44. Which of the following statement not correct? Not correct. Catalyst does not initiate a reaction, that is right. Catalyst can only increase the speed of a reaction already occurring. Value of equilibrium constant changed, that is where it is wrong. It is wrong. Value of equilibrium constant remains the same. Therefore, that is where it is wrong. Enzyme catalyze mainly biochemical reaction, correct? Coenzyme increase the activity, that is also correct. So wrong will be 2. And 45 will be an organic question. Again, it is very simple. You know, copper, heating with copper at high temperature is a method of dehydration of alcohol. It's a method of dehydration of alcohol. Primary alcohol will give aldehyde, secondary alcohol will give ketone, tertiary will give alkenes. There is a reaction. So this indicates that this should be a alcohol. Then A should be either aldehyde or a ketone, because it is given a silver amino complex gives a silver mirror, it indicates it is aldehyde. So here is an alcohol which will give an aldehyde on heating with copper. What can be the possibility then? See, there is something given as in the reverse order. This is A. This is A. So that should be aldehyde. So A is an aldehyde mean this is the only possible answer. It is not X. A is the aldehyde. See whether the remaining is correct. If this is A, this will be ethanol. Ethanol dehydrated to ethanol. That will answer tolerance test. And ethanol will, what is this reaction actually? Slightly complicated. See, ethanol. When treated with alkali, it will undergo aldol condensation. Aldol condensation. First aldol obtained will be CH3, CHOH, CH2, CHO. And on dehydration, it will eliminate water giving CH3CH, double bond CH, CHO. It is this compound that is Y. But-2-enol, 1, 2, 3, 4. So here you have got application of aldol reaction. I told you there are 3 or 4 questions which are difficult. One was that series substitution. So many. So this is also a slightly difficult one. The other one was that uncertainty principle relation. Like that there are some difficult questions. So Y is this compound. And naturally aldehyde can react with, what is this compound? Semi-carbazide. That can give, what is this compound? Actually it should be NH2. What is given is semi-carbazone. This compound is called semi-carbazide. NH2, CO, NH. NH2 is called semi-carbazide. And it is here that aldehyde will undergo condensation. So that should be the semi-carbazone. So your answer is 3. Which of the following reaction is appropriate for converting acetamide to methenamine? Acetamide is CH3CO, NH2. Acetamide, also called ethanamide. You have to eliminate this CO to get CH3NH2. Carbon you have to eliminate. Such elimination of carbon is possible with only one reaction, that is carbylamine reaction. Treatment with bromine and alkali. We will take away CO and that will be eliminated as K2CO3. That reaction is called carbylamine reaction. You know the different steps are there. First you will get CH3CO NHBr. NH2 will be brominated to bromoacetamide. Naturally, HBr will be removed by alkali. So we get CH3CON, which is unstable. So that will immediately rearrange to CH3NCO. That is the compound. And that will undergo hydrolysis by the same alkali, where H will be there, OK will be there. Read it as KOH. 2 molecule, HOK, HOK. And this part become CH3NH2, which is our required product. And the other part become K2CO3. So you got a reaction where carbon is eliminated. Such reactions are generally called in organic chemistry as degradation reaction. Degradation means reduce the number of carbon. Upgradation means increase the number of carbon. So this reaction is one where you have got degradation. You actually call it Hofmann degradation reaction. So what is that reaction here? Oh, it is Hofmann bromamide reaction. The answer will be Hofmann bromamide reaction. Answer is 2. Why do you call bromamide reaction? You start with an amide, you are getting bromoamide. It is this compound that is indicated in the naming. It's also called degradation reaction. It is also called degradation reaction because carbon number is reduced. In 1 year, this has been asked. Finally, what will happen to the Cu in the original compound? The answer was it is eliminated as carbonate. Options given will be by carbonate. So many things are given. Carbon monoxide is finally eliminated as carbonate was the answer. That's why I gave you this also. Okay, this will be K2CO3. That was a question, earlier question. So that by thereby you complete this paper. Not an easy paper anyway, but you will leave that difficult question which will be there 3 or 4 questions. You will leave it, that's all. Even then, you can be confident of getting high score. Okay, that's all. Thank you.